about IP addresses before, but we sort of haven't really formally talked about. Is that large enough? Do you want it bigger? Is that big enough? Is that legible? Nick, is an IP address? An IP address consists of four octets. So it consists of 4 numbers that are separated by dots. It's a 32-bit address, as I mentioned before. So it's going to be 8.8.8.8 bits long, so it's 32 bits. Now, seeing as each 8 bits, so with 8 bits, we can go from 1, 2, 3, 4, 5, 6, 7, 8. We've done binary, so we know what this means. And that can go to 1, 2, 3, 4, 5, 6, 7, 8. That is the sum total of our binary address space with 8 bits. What that means is that with this number, 8 zeros is still 0, and that can go all the way up to 255. So these two numbers, we should know that they're what they are. Okay, so 0 to 255. So we know here with these octets, 0 to 255, 0 to 255, 0 to 255, 0 to 255. Okay. So when we have an address such as this, 192.168.9.20, this address has some meaning. When I look at it, I can see a whole bunch of things that I can infer. At the moment, to you, it's just 4 numbers. 4 numbers that are in this range. Okay, be aware that we can't have numbers higher than 255. So if you ever see an IP address with numbers higher than 255, they'd be wrong. But usually when you see an IP address, you don't see it on its own. You will usually see, associated with it, a subnet mask. Something like that. And the subnet mask gives this meaning. The subnet mask itself infers a whole pile of stuff on this guy. First of all, subnet masks start from the left and move to the right. And for now, just think of them as 255s. Wherever there's a 255, that changes the meaning of this number. So we have 255s and we have zeros. Where there's a 255, that is the network address. Network address. Address. And wherever there is a 0, that is the host address. So remember we were talking about IP addresses like endpoint to endpoint, my house to your house. When we use that analogy with these two concepts, the network address is like your street address. So the network address is like a street address, and the host address is like your house number. Okay. Now, if we have that, if we have street address and house number, that makes a lot of sense, because if you think of a typical street, think of your street. In your street, every house, if you're going to send some mail to the house in the houses in your street, they would all have the same street address. Or third one. They're all in the same street. That's right. Same thing with computers in the same network. Every computer in the same network has the same network address. Similarly, if you were to send if you were to number the houses in your street, every house in your street has got a unique number. So every house in your street has a unique number because it needs to be uniquely identified in your street. Same thing with the host address in a network. The host address in a network needs to be unique for that network address. So for instance, in this network, 192.168.9, these numbers here can go anywhere from 0 to 255. Okay? Because that's what we set up here, 0 to 255. So 192.168.9.0 up to 192.168.9.255. All the available addresses can't go higher than 255, which means there are 256 addresses in this subnet, 0 to 255. Okay? Now, there are some rules, much like with your street, there will be rules inside this, but they're a bit weirder. First of all, you can't assign 0 as a house address. The reason you can't assign 0 is because 0 is the network address. So 0 refers to the network address. So whenever I want to refer to my network, I don't call it 192.168.9 or 192.168.9 network. I call it the 192.168.9.0 network. Okay. All of that refers to the network address. 10.1.1.0 network. I don't call it the 10.1.1 network. It's 10.1.1.0 network.
So if you want to send a broadcast, you send it to that one?
255.
No.
The last one.
This is the network address. It's for you to refer to the network. If you want to send a broadcast, you send it to every address in the network, which is specified by all ones. So 255. So that's the other address that you can't use. You can't use the very first address and you can't use the very last address. The very first address is the network address, so it refers to the network, and 255 is every address, the broadcast address. So this is just the general rule of thumb now, because we're using very simple kinds of networks. They will get more complicated, but here we're just using a very basic kind of network, and it follows these basic general rules. These are called classful rules. It's all based on classes and stuff. It's very simple. We're going to go through classes and everything soon, and we'll talk about how IP addresses work. But in this case, it's a very simple network: 192.168.9.0, which is the network address, 192.168.9.255, which means as the broadcast address, which means the usable addresses are 1 to 254. That's the usable address range. And the main thing there is that we don't want duplicates. Duplicate IP addresses cause problems. We don't like duplicate IP addresses because when we transmit to 192.168.9.10 and there's 2 of those, it's difficult to work out who to deliver to.
So there's a correct terminology that's not assignable as opposed to usable, because you can still use a 255 as a broadcast, so it's not assignable.
Yeah, time with that question too. So what they did was they said, look, we've got this address range. We've got 0 to 255.0 to 255.0 to 255, etc. What we're going to do is we're going to set up some classes of address. It's the 1970s. There's like 16 computers on the internet. How many computers are we possibly going to need? But what we'll do is we'll think big. Let's set up some classes so we can use these addresses advisedly. So what they did was they said, well, let's create some networks. We'll create the A network, we'll create the B, class B network, class C network, class D network, and class E network. Okay? And they said, what we'll do is we'll look at this number here. This number can go from 0 to 255, right? So what we'll do is, based on what this number is, we'll create a different class. So class A will be addresses from 0 to 127, right? Class B will make that from 128 up to 191. Class C will be 192 to 223. Class D will be 224 to 239. And Class E will be 240. This is going to answer your question. It doesn't look like it is, but it's going to, up to 255. Okay? Then what we'll do is each of these is going to have a different size one of these. So over here, what we're saying is this and this and this are part of the network address, which leaves only this poor little number for host addresses. So with this one, what we'll do is we'll have a subnet mask of 255.0.0.0. So that means the first octet is going to be for network address. The last 3 octets are for host addresses. So this is for a really big network. over here, you can see where this is going, 255.255.0.0, and this one will be 255.255.255.0. Over here, this is going to be reserved for a specific type of transmission that we're already familiar with, multicasting. So with multicasting addresses, we use anywhere between 224 and 239. And this one, in their wisdom, they reserve for experimentation. So this is, you'll either see it reserved as E for experimentation, or you'll see it just says reserved. Okay, reserved for future use. So you can think of it as experimentation or reserved, but you can't use any of those. These you have to use a specific way, and then over here we've got the more general usable addresses. Okay, so over here, how many hosts can we have? Well, we can have 256 times 256 times 256, but you can't have all zeros, and you can't have all 255s. Okay, so 256 times 256 times 256 minus 2. Yeah, so 256 times 256 times 256 is 16,777,216 addresses, which you can't use 2 of them, so it's 214 addresses. Okay, over here,
65,000.
same thing, 65,534. So 65,536 minus 2, and over here 254, as we discovered up here somewhere. Okay, so if you don't want 254, if you need more than 254, you can get a Class B that's going to handle 65,000. And if you got more than 65,000, well, you can go for a Class A, which is 16.
But in this way, you are changing the network size, which is not exactly the same as street.
You're going to a completely different network here.
Yeah. Literally, you just reach the limit. You can't have 255 houses on the street you want.
Yeah, so you have to go to B. So you can see the problem here, right, with what Wiener is saying. If you are using 192.168.9.0 as your network, once you get to the 255th computer, you go, oh, I can't use Class C, I have to have a different network altogether. And let's say you've got 300 computers, you have to get a Class B network. If you've got a Class B network with 300 computers, you've got plenty of addresses, but look how many addresses you're not using. 65,234, so nearly all of them. So instead of being able to extend this a little bit, you've got a very inefficient use of this network. You're not using most of them, but that's okay. You've got a really big company, and that company grows like crazy, and now you've got 70,000 employees. 70,000 employees with 70,000 computers. You have to go from a Class B to a Class A. How many addresses are you not using here? 16.7 million, nearly all of them. 70,000 is a scratch in the oceans. Scratch in the ocean.
Drop in the ocean.
Drop in the ocean, thank you. Drop in the ocean compared to the full address space. So what you're seeing here is a very inefficient use of the IP addressing system. Using a classical system like this was great in the 1970s, when it was like, we got so many IP addresses, we don't even know what to do with them. Let's be wasteful and do this. But in actual fact, everyone wanted the internet. Everyone wanted to TikTok and Facebook and eBay. And now we've got a problem that there's not enough IP addresses. There's more devices on the internet than there technically are IP addresses available. There's more than 4 billion devices on the internet. How is that possible, Michael, if there's only 4 billion possible addresses? And we've wasted a big chunk of them doing this and this. We'll learn about that soon. The main thing is that you understand how to read an IP address. So if I gave you an IP address such as this, let's go with what is the network address?
B.
You haven't given us a subnet mask, Michael. Okay, but based on the default subnet mask, what class is this B?
Is it B?
It's B, so we
255.255.00.
255.255.0.0, which means that the network address is what?
First two octets. 137.19.
Is 137.19.0.0. Network addresses always have 4 bytes. Okay? So in an exam, if they asked you what is the network address, you make sure there's always 4 bytes. 137.19.0.0, and the host address would be 45.26. So this is number 45.26 on 137.19.0.0 stream. Okay. How eye-opening is that? If you haven't seen that before and weren't aware of it, do you want another one, or are you good with this stuff? You okay?
Yeah.
All right. All right. I'll give you one more just in case. 10.1.2.3.
A.
Say, which means
255.
subnet mask will be 255.0.0.0, and the host so it'll be 10.0.0.0 and
123.
Okay, 1.2.3 on 10.0.0.0. Okay, does everyone understand how that works? Address like this. What have we got?
Is it D?
It's class C. So it's 2.5.2.0. So you got to remember the demarcation points. 1 to 127, 128 to 191, 192 to 223, and 224 to 239. They're the important ones. That way you know this is 209.165.200.200.0.
It doesn't always have to be 0 with the last octet in subnet mask.
For now, yes. Later, no.
Why is it always 0? When is the case is being used for?
But the host portion must be all zeros. And the broadcast address, 192.168.9. And this is in binary now, 1, 2, 3, 4, 5, 6, 7, 8. Okay? So the host portion needs to be all zeros for the network ID, and the host portion needs to be all ones for the broadcast address. But if you think about it, if you look up here, this is a really inefficient way of breaking up your IP address space, right? Because we're jumping 8 bits. So this is 8 bits, this is 8 bits and 8 bits, this is 8 bits, 8 bits, then 8 bits, then 8 bits. So this is 8, this is 16, this is 24 bits. Okay. And by that we're talking about the network portion, right? 8 bits, 16 bits, 24 bits. Why do you have to jump by 8? You don't have to jump by 8. You can do anything you want. So to highlight to you what I'm talking about, if you think about the subnet mask in binary, the subnet mask is this: 1, 2, 3, 4, 5. So in decimal it would have been 255.255.255.0. But in binary, that is 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Okay? And if you look at every one of those, class A would be 1, 2, 3, 4, 5, 6, 7, 8. Dot. And a class B would be okay? So if you take a look at what we've done, we've gone 8 bits, then 16 bits, then 24 bits. But who said you have to jump by 8 bits? Why can't we? Notice, first of all, let me just highlight something. The network portion, or the ones, always start from the left and move right. The zeros always start from the right and move left, and then they meet somewhere, okay? See that? So now we've got all zeros, now we've got all zeros, now we've got all zeros, all ones. Okay, so the ones start on the left, the zeros start on the right, and then they just meet somewhere. But there is no reason we can't have a subnet mask like this. Crap. That just made it more complicated, right? And there's no reason we can't have a subnet mask that looks like this.
Yes, you can.
Okay? And to answer your question, Jason, there is no reason why we can't have a subnet mask that's like this.
Yes, you can.
And all we need to know now is how to represent this
To decimal.
in decimal, yeah. And all we do is just, same way we did before, is just work out what these numbers are in decimal. So this would be, for instance, 255.240.0.0. This would be 255.255.254.0. And this one would be 255.255.255.240. Okay, so they're examples where this is an example where there's no zero. Okay, why would you want to do that? Because we only need so many bits. We don't have a huge network. We only want a small amount of computers. Because we've got 4 bits available for our, over here we've got 4 bits available for addressing our computers. That means we've got from 0, 0, 0, 0, let's work it out. We've got from 0, 0, 0, 0 up to 1, 1, 1, 1 for addressing. And the equivalent of that is 0, 0, 0, 0, well that's still 0, and that's going to go up to 1, 1, 1, 1, which is 15. Now we can't use this one because this is all zeros in the host portion. So that is, that's the network address, and we can't use this one because this is the broadcast address because it's all ones in the host portion. So what we can use is 1 to 14. Okay, that's moving ahead a bit. This is not where I wanted to go, but it sort of flowed on naturally. If it has confused you, I apologize. Hopefully it's just, I don't want you to fully understand it, I want you to be aware of it, okay? The main thing to realize before we go on our break is that this is what's currently being used. It's less confusing, but it's inefficient. It's a very bad system. And so in order to use our IP addresses more effectively, we can use more granular subnet masks, or we can use what are known as classless. This is class full. I need to change that. Class full addressing. To go from class full addressing to classless addressing, we don't stick to the boundaries set by class A, class B, class C. We can move our ones, we can adjust our ones and zeros however we want them. Basically, you don't subnet, you typically don't subnet in this portion, okay? So you don't really need to worry about that, but you can just adjust this slider bar to go up and down here, however you want, so that you've got the right amount of host addresses, the right amount of networks, okay? But you don't need to worry about that just yet. I'm just making you aware of IP address. We took a couple of quantum leaps there. You will know this inside out later. You'll look at it and go, oh yeah, I can see what that means. It's just going to be second nature. But for now, my main goal is that you understand what the role of the subnet mask is. An IP address without a subnet mask is just short of meaningless. You can infer some meaning if I gave you any address. So if I gave you something like this, 131.16. 24.0, not to 0.15 for instance. You've got
255000.
So you've got a whole pile of information you can infer there, right? What class is it?
B.
It's a class B. So it's 255.255.0.0. And that means that you know that the network address is 131.16.0.0 and the host address is 24.15. You could also know, looking at that address, what other IP address you can use now if you needed two computers to talk to each other. So you can go 131.16.224.16 and that will talk to it. Or you could go 131.16.100.100 and that would work. But you know if they put 131.17, it will.
It's not going to work.
Yeah. So a lot of information. Let's take a break before you